Here's another binomial we want to factor. Remember, step one, whether it's a trinomial or a binomial, is look to see if you have a common factor we can divide out. Now, hopefully we can recognize that 50 and 2 both share a common factor of 2. So I'll be able to divide a 2 out of each of those terms. And also, what do we notice as far as variables? Both of those terms have y, don't they? This term has y to the first, this term has y to the third. I can then factor out the one they share in common. The one they share in common is y to the first power. So I can divide out 2y from each of those terms. When I take this term and divide it by 2y, 50 divided by 2 is going to give me 25. There is no x, so the x squared stays the same. Y divided by y is 1. And 1 times 25x squared is just 25x squared. Minus 2 divided by 2 is minus 1. And y to the third divided by y is y to the second. So I've factored out that common factor. Now, if this binomial is factorable further, it has to be that special pattern, the difference of squares. Difference means it has to be a subtraction, which it is. To see whether or not it's the difference of squares, let's again fill out our squares skeleton. So let's look here and see if we can fill out the squares skeleton. What could I square that would make 25x squared? Well, wouldn't 5x times 5x give 25x squared? That'd be squaring 5x, wouldn't it? What can I square that would make y squared? Well, that would be y times y, wouldn't it? So this is the special pattern, the difference of squares. The difference of squares always factors into two binomials, one with addition, one with subtraction. The term that goes into the first positions of the binomials is the term that was in the first position of your squares skeleton. So 5x goes into each of those positions. The term that goes into the second positions of the binomials is the term that was in the second position of our squares skeleton. That's y. And we have the factorization of that original binomial. It again, after we factored out the common factor, do you see that? Do you see that this would not have been the difference of squares until we factored out that common factor of 2y, and then the difference of squares was revealed. That's why it's so important to factor out the common factor first if one exists. Once we did that, we saw that we had the difference of squares by looking at our squares skeleton, and we were able to write the factorization of that binomial.